This is a quick video on factor strings and factor trees. You're going to use this skill when you come back to class tomorrow. The goal today is to be able to take the number 24 and understand what a factor string is and make different factor strings, and then take the same number 24 and make factor trees, because both of these skills help you solving lots of math problems. And then the last thing will be to use the factor trees to find the prime factorization of 24. So first of all, let's take a look at the number 12. The number 12 has different factor strings. A factor string is just a set of numbers that multiply to give you 12. For example, this is a factor string. 3 times 4 is a factor string because 3 times 4 equals 12. So we call that a factor string. And another factor string is just 2 times 6 because 2 times 6 equals 12. Those are kind of short factor strings. You could also make the string longer, stretching it out by saying 2 times 2 times 3 is 12. So that's another factor string. So a factor string is just a string of numbers that are multiplied together to give the desired result. A factor tree you might have done in elementary school. A factor tree is where you take the desired number 12, for example, and find two numbers that multiply to give you 12. So behind that star is the factor pair of 2 that times to give you 12. Hopefully you guessed 6. So now, I bet you get the idea. Below the number 6, we have another tree, and we continue making little branches until the bottom of the tree is all prime numbers. So since 2 is a prime number, I circle it because I know I can't do any more branches. Now 6 is not a prime number, so I have to think of 2 numbers that multiply to give me 6 and put them at the bottom of my tree. So think about those 2 numbers and see if you're right. 2 times 3. Now the bottom of my tree is prime numbers. Once the bottom of my tree is all prime numbers, I have a completed factor tree. Some of you might be thinking that you might have started with a different factor pair. That's what this tree over here is. So there's other ways to multiply 2 numbers to get 12. For example, 3 times 4. So 3 is a prime number, so I'm going to circle it. 4 is not a prime number, so I'm going to make new branches below it. Now I have to think of 2 numbers that multiply to give me 4. So think about that. And we don't use the number 1 in factor trees, so the only other choice is 2 times 2. Now the bottom of my factor tree is all prime numbers. And if you notice, the bottom of the tree in green has the same prime numbers, 3, 2, and 2, as the bottom of the factor tree with the blue, because they both start with the same number. So if you use the same number, you should get the same result. Finally, the last term is called the prime factorization. The prime factorization is your longest factor string. So if you take the bottom of your tree, for example, the bottoms of the tree here, 3 prime numbers, and multiply them together, 3 times 2 times 2, you end up getting 12. So we call this the prime factorization because it's a factor string with all prime numbers. Another way to write it is with exponents. We're going to work more on that in class. But for those of you that have seen exponents before, since there are two 2's right here, we say that's 2 to the second power. And then there's only one 3, so we just say 3. So that is the prime factorization using exponents. And this is the prime factorization without exponents. Okay, let's look at the goal again and see if we can do these together. So, we're going to list some factor strings through 24. I can think of one starting with 2. 2 times 12 makes 24, so that's one factor string. I can make a bigger one. I could say 2 times 2, that's 4, so times 6, that would be 24. Or maybe I want a different one altogether, and I want to say 4 times 6 is 24. So those are 3 factor strings. I wonder if you can think of some other ones. The prime factorization is the longest factor string. So sometimes the easiest way to find the longest factor string is to use a factor tree. So how can you use a factor tree to find the prime factorization of a number? I'm going to show you that right now. We practice that on the left side of the page. Remember, all of these numbers are factor pairs. Now we're going to create our own factor tree over here. So I'm going to just pick 2 numbers that multiply to give me 24. For example, I could start with 4 times 6. Since neither 4 or 6 is prime, I make branches under them. And I put 2, I make a new factor pair. For example, to get the number 4, I will multiply 2 times 2. Since 2 is prime, I circle it because that reminds me I'm at the bottom of my tree. For 6, since 6 is not prime, I make branches under it. And I think of 2 numbers that multiply to give me 6, like 2 times 3. Since 2 times 3 makes 6, and 2 and 3 are both prime, I circle them. When the bottom of my tree is all circled, I'm ready to write the longest factor string, which is 2 times 2 times 2 times 3. Because 2 times 2 times 2 times 3 is equal to 24. So the prime factorization is just 2 times 2 times 2 times 3. And if you want to use exponents, since there's 3 2's, we say 2 to the third power. That means there's 3 2's times 3. Let's try that one more time using a different factor pair. Instead of using 4 and 6, we could use 3 and 8. In fact, any factor pair of 24 will work. Since 3 is a prime, we circle it and we don't put branches under it. Since 8 is not prime, we put branches under it and make a new factor pair for 8, like 2 times 4. Since 2 is a prime, we circle it. Since 4 is not a prime, we put branches under it. and found another factor pair for 4, like 2 times 2. And now the bottom of our tree, even though it's more lopsided, it's all primes, and if you look, you see the exact same numbers, 2 times 2 times 2 times 3. So the prime factorization, which is also the longest factor string, can be found using a factor tree.